So one reoccurring problem I keep having with my Samurai is this power steering belt. At high RPMs, it likes to fly off. So this is a PSC pump, a low range off-road bracket, which is a piece of crap. I will be replacing this at some point. So what happens, you can rev this thing up, like, sitting still in neutral, and the slack side of this little serpentine starts doing this number, twisting back and forth, much faster than this, obviously, when it's running, but, at about 6,000 RPMs, it really starts whipping. The tension side seems to stay nice and straight. It's just the slack side. And so it starts whipping, and then at some point, this angle here where it meets the pulley makes it basically skip over a tooth, and then a tooth, and then it flies off. So my solution right now is I'm going to try to add an idler wheel. This is a little 4-rib idler wheel. This came from some sort of a Hyundai. But I'm going to put this guy right here and just put a little bit of pressure on that slack side, and that should hopefully control it. I'm pretty sure it's like picking up a harmonic, a vibration from the engine is just matching the frequency of this thing. So by putting the wheel on there, I'm basically breaking this slack side into 2 pieces, which should have, a vastly different resonant frequency and not pick up that harmonic. So this guy's gonna sit right about here. It's kind of a pain because there's very little room to work with. But I've got a stripped down cylinder head, and I'll show what I've got, what I'm working with, and what my ideas are. Okay, so here's my cylinder head. I've got it upside down because I don't want it to rest on this surface. This is a freshly remanufactured head. But basically, well, I'll stand it up, I guess. So this is the front of the engine. So there's 2 threaded holes here that aren't being used. These, I believe, are M10 holes. And then there's 2 on this side that are M8s. The power steering bracket, that low range one, does use these 2 holes, but in that previous clip, you can see there was aluminum spacers there. So I'm gonna have to shorten those spacers because the bracket is gonna slip in there. So I'm gonna have a bracket that bolts onto here, comes out, and bends to make a flange in the same plane as the front of the head. And then the same thing on this side, the bracket will come up and then out. And then I'm gonna make basically so there'll be these 2 pads, and there'll be like a bridge that comes between to hold this wheel in the right spot. And all these parts have kind of a goofy shape to them. I've got my first rendition of the parts drawn up. I'm going to get them cut out and see how it all fits together. With the timing cover and everything in place, it's real tight, in clearance with the fan. And luckily, having a bunch of stuff laying around like the cylinder head, and I've got my other engine loose. So at least it makes it a lot easier to measure, because getting down in the car is a real pain. But basically this pulley is gonna sit just, outside of this edge of the timing cover and about right here. So the piece that's gonna mount here and on the other side, the bridge part between them is gonna have to kind of swoop under this bulged out part. I think there's enough clearance for everything, but it's gonna be pretty tight. And then eventually, I may expand upon this bracket and do something different and actually mount my pump to that also. I kind of don't like the system that they use now that grabs 2 holes down here on the block and then 2 on the head, because there is, the thing doesn't seem to fit perfect. There's some, tolerance stacking issues between, mounting to 2 different pieces, especially on engines that have been machined, over time and stuff like that. So if this seems strong enough, unfortunately it's got the smaller bolts on this side, but maybe I don't know, that's down the road. But I think getting this guy on here is going to help a lot. And my short-term solution to this belt flying off while I'm out in the sand dunes or racing or whatever is just not revving it as far. Initially I had my rev limiter set at 7,000 because that's where it peaks in power, like at 6,900. But I really, revving it much farther than that kind of has always scared me a little, just for longevity. So I had the rev limiter at 7, and that belt will just fly off every time. So then I went in and changed my limiter to 6,500, and that seemed to help for a while, but now it's doing it again. And, that belt's been on and off a couple times, and just the tension, how tight that is, I'm sure changes its frequency. So it's just that's a poor solution. And plus I'm losing a little bit of power with shifting it. I don't run it to the rev limiter when I shift, but just using that rev limiter is kind of a training aid to get used to when to shift. Because when you're really, on it, thrashing through bumps and whatever, I don't really watch the tack. So I'm gonna go to the computer and I'll show these brackets, and then I'll get them cut out and see how they fit. Okay, so here we are with my drawing. And again, this is where not being proficient in 3D software is kind of a pain. But so these 3 rectangles are basically super simplified views of the cylinder head. And so this would be the side with the larger holes, the intake manifold side. And so I just basically measured very carefully where the holes are in the head, then the width of the head and all of that. And it kind of came up with a profile that cleared everything. And then, this is a top view. So those brackets are actually going to extend. This is the front face of the head. So the bracket is going to extend out to clear the timing cover. And then this will be 3/8 thick steel piece that will go from bracket to bracket. And then the shape of it, like I showed before, is going to have to swoop under the bulged out section for the cam sprocket. For the first one, I'm going to make this adjustable. It really doesn't need to be, but the whole thing will pivot on this side. But just as far as like kind of a rough draft version of this, I figured I'd make it adjustable. And then depending on how it works out, I may or may not, I might make a new bridge piece that just has 1 hole. Yeah, so this is the pulley, and I think it's going to work out pretty well. It should be pretty stable, pretty strong. I'm going to make each of these mounting tabs out of 3/16, and then this piece is 3/8. And that gives me enough room to get in. There's room for the bolt that's going to pass through this. Should be room for a bolt, and slipping a wrench in there to hold it. The nut will be on the outside. And I have about a 1/4 inch space basically around everything. All the plastic cover, the fan, there's enough room to get tools in there. So I think this is going to work out pretty good. And like I said, eventually I would like, if all this seems really solid and stable, I would like to expand upon this side and and maybe even just off of this plate, incorporate the pump bracket into this. And because I think that low range off-road bracket, it really flexes, because it's just basically a T-shaped piece, and there's really not much support, and the bracket itself mounts to the back of the pump, and so there's even more leverage placed upon it because of that. Whereas if it was mounted to the front face of the pump like it should be, the support would be a lot closer to the pulley. So eventually I'm going to do something to fix that up. So yeah, so these are the pieces flattened out. These two lines represent the bend allowance. So the bend will be hit right down in the middle between these two lines. This hole here is for this guy, and you see it's got a slight oval to it. I try to always do that on things that are kind of I don't know how to, I measured this head really carefully with calipers, and all this should be really accurate, but I'm still dealing with two bends. I've gotten pretty good about getting my bends just right, but still giving that just a little wiggle room. And then on this side, you can see this is the diameter of the bolt I'm going to use, which is 3/8. I give it 20 thousandths on either side, just so this slot can sweep by the bolt easily, and then also gives a little room for error. If you make all this stuff just dead nuts, then it's just a battle. I mean, if you get lucky and it's perfect, then cool, but having a little wiggle room is always nice. So, yeah, then this is the other side. I'll delete these lines out, but these are just for a visual reference where the bend goes. And then, I take and accurately measure so I know where to set my press brake at. So that's that's where my backstop is going to be set. And I set it off of the nose part here on both of them because they have the same offset there. And this is different side to side. So that way I can just do one press brake setup and bend both parts. So I'm going to get these parts cut out and give it a try. This has been a pretty irritating issue with my car, and I'm looking forward to getting this fixed. And at the same time, this winter I'm going to be sticking that motor in it with a turbo. But the last thing I want to do is get that engine stuck in first and, still have this power steering issue. So I definitely want to get the belt issue solved before I put this in. If this becomes an unsolvable issue, which I don't think it will be, but, if this doesn't work, my next thought is switching everything over to a V-belt, which I don't like because they don't seem to grip as well, but they're a lot more tolerant of misalignments and stuff like that than a serpentine is. So if this doesn't work, I'll switch to a V-belt. And if I have issues with that, then I think I may go to a electric over hydraulic pump. I've been researching those quite a bit. It seems to be the most common one people use is out of a Volvo SUV. And there's companies that build harnesses for them and, the proper fittings and stuff. And then you can remotely mount that thing basically anywhere you want. And I'm not sure what the pressure is, though. That's one thing I'm a little scared to do any major changes with my steering system is I'm really, really happy with that pump. I believe it's a 1650 PSI, and it's got a high flow rate. And so it keeps up with steering fast, and it's got plenty of power. I don't run a RAM assist with it because I just haven't needed it. that pump paired with that tow to steering box, it's pretty powerful. So I'm hoping, I'm hoping this is the fix, and I won't have any more issues. But I try to have a plan B and C in place too while I'm sorting this stuff out, just so I have somewhere to go if this doesn't work. So I'm gonna get these cut out, and then we'll do some test fitting and see how she looks. All right, so I got some of the brackets cut. This is some 3/16 HRP no steel. I figured I'd show how I like to clean small parts. I use one of these switchable magnets. This is made to be a ground for a welder. You can just stick it to your work. But it's handy because you can turn the magnet on and off. So I turn the magnet on to hold my piece. And then I use this cheap Harbor Freight belt sander. I've had this guy since about 1999, I believe. And it's been super reliable. Not very powerful, but it gets the job done. And then I just take the piece. Get a nice clean surface with no grinder marks. Nice even, like a grain. So that's the way I like to do it. So I got these two parts cut, and also that bridge piece that goes across. I've got to clean that up and then get these guys bent and do a test fit. Okay, so I'm mocking these pieces up and made a couple mistakes. So this fits pretty good, and it just clears this, even if it's up above it. But I totally forgot about the water pump pulley. I also goofed up the length of this bracket. Had a math error when I was finding the spacing on, or the offset on these holes. So now what I think I'm going to do. Basically got this hole, the vertical orientation is in the middle of those two. I'm going to move it up even with this hole, so this point will come up a little, and then I will do the same thing on the other side. And I'm probably not going to have this adjustment anymore. If I do, it's going to go to this side, and so I'll probably basically go straight across. I was trying to keep it kind of scalloped under this, but whatever. So I'm going to go straight across and then come down to this point where my pulley's going to mount. So I need to go out to the actual Samurai. I'm going to measure that. Actually, I have a pulley. I'm going to stick this pulley back on just so I can make sure that with a belt between those pulleys, I'm not going to have any more issues. I've got this basically designed now for a 1/2 inch tall spacer. I've got some aluminum spacers that are 1 inch diameter. They just fit inside here, and they're made on a lathe, so they're all straight. And I need to go double check this orientation, or this height, make sure that's going to actually do something. So maybe I'll move this adjustment slot to this side so that I've got some room to play with it. So back to the drawing board. I'm going to come up with a new design for this piece. I've already changed these up. So try it again. That's just kind of the nature of these things. Doesn't always work the first try. Okay, we reworked these parts. I changed up the bracket that goes on the intake side of the head. I changed that up a bit. I had to basically raise the bottom up to clear the, this used to extend straight out tangent with this arc here and then up. So I kind of scalloped that part out because this extends out over the water pump pulley. So I had to gain some clearance there. And then I changed the shape of this front bridge. This used to come out and then up. So now it goes this way to help clear that pulley, which sits about here. And like I said before, I put the pivot on this side and the adjusting slot on the other side. And this bracket also changed. This hole here used to be down about here, so I raised that up. So basically I have to remake everything, but it's just what it takes. So I'm gonna get this stuff recut and see how it fits this time. All right, here we go with the second attempt. This one looks a lot better. See, I raised the bottom of that bracket up to clear this pulley, and there should be plenty of room. I may modify this again and take some of this off, but there's plenty of room for the belt to wrap around this. And we got the bracket bolts the side of the head, and got some adjustment to control how deep this guy is going to push into the top of that belt. So now I've got to come up with some hardware. Got to ream this hole out, put my spacer in there, and bolt this guy up. And I think it's going to work. I ended up going with 1/4 inch on this. Originally I planned on 3/8, but honestly I'm not going to be pushing very hard into that belt with this. This is really more just to deaden that vibration. So there's no sense in adding a bunch of weight to this thing. Kind of bummed about this. Just looks goofy, but it's not a show car. So pretty happy with this. I am probably going to give this a try on my next trip, and then I really hate the bracket that holds the power steering pump. I may build a new plate, you know, now that I've kind of got an idea of the fitment of all this, build this all beefier, maybe do 2 holes and make this bracket extend out and then be cut out with the proper shape for the power steering pump to bolt to the back side of it, and be kind of a one-piece unit for the idler and mounting the pump itself. But I don't know, pretty happy. I'm gonna give this, like I said, give this a try as is. You know, play with this adjustment and figure out where the sweet spot is. And then once I know, then I'm gonna get rid of that slot and make a new one that's just got a hole. Because I don't want any extra movement, because the tension in the belt is handled by the pump. It's in a slotted hole. Just kind of did this because I wasn't sure, you know, the proper depth. I kind of thought about doing a couple different holes, maybe like 3 holes at an angle this way, kind of into the belt, so then I could play with it that way. But I really don't have a ton of places I can put this where it doesn't interfere with things. So fits the engine. Now it's just a matter of making sure that it's going to solve the problem. And then my next project is rebuilding the motor mounts. I did a video a while ago where I built the engine side. So what I'm going to do now that I've got this stuff all figured out is I'm going to build some brackets that bolt here with these same places on the head and extend up, and then I'll do a piece of tubing across my roll cage so I can suspend the engine in place where it is now, and it'll stay exactly where it is, and then I can disassemble all of that stuff on the frame side motor mounts, cut all the original stuff off and build new ones, you know, in place. So I guess that wraps up this project. I'm pretty excited and nervous. I'm trying to get all these little things done so I can put this motor in with the turbo. I don't want to be, you know, waiting on this little stuff. I want to just drop this in because I've got to get this thing retuned, get the the ECU retuned. So try and get all the little crap done first. So that's it for now. I have seen other people having issues throwing belts with this same kind of system that I have. So if this turns out good and really works, I'm going to add it to my list of parts that I'm working on developing to sell. So until next time, thanks for watching.